Power lab when you had to run and walk up and down the stairs. So the first thing I want you to know is about energy here. And energy is the ability to do work. We measured that in joules. And work is going to be sort of the, similar to that. It's the product of force over a distance. So if a force goes over a distance in the same direction as the work, you simply multiply those two things together. All right, so if it's the product of force over a distance, I'm going to simply take this weird looking formula here. W is going to be equal to work, equals F, which is force, D is distance. I'm going to put that little cosine theta there. We'll explain this a little bit later, but that's how we're going to make sure that the force and distance are going the same direction. So let's do this practice problem here. I got Miss Kaylee. She's the greatest. I want to know, what work did Kaylee do if she weighs 500 newtons? Now that's about a 110-pound person, somewhere around there, and she climbs a 3-meter ladder. It's not a stairwell, it's a ladder. I'm going to scratch out that. So what we're going to do now is we're going to take that and plug these numbers in for that formula. So what we're going to do now is we're going to plug in the numbers that we have here. So Kaylee's force was her weight of 500 newtons. Her distance was the 3-meter ladder. And since the ladder is going straight up and her force is weight, which is also going straight up, we're going to have a 0 angle between her force and her distance. And the cosine of 0 degrees is 1. So you take the 500 times the 3, and that gives you 1,500. And work is measured in the same unit as energy, so you're going to be measuring it in joules. Okay, now we're going to pretend that Kaylee is going up a stairwell like the one you're going to have. You're going down stairwell C, D, or E. And the stairwell itself is much longer than the height. The height might have only been 3 meters here, but the distance is 6 meters. Okay, so you're going twice as much distance. Now you still got to lift the 500 newtons of force, so I'm still going to put 500 newtons in for F. I'm going to put a distance in of 6 because she's going up the incline now, like this. But since you had the angle, we're going to have to put the cosine of 60 in there. Well, guess what happens? You get the same answer. So you're going to do the same amount of work whether you go up a set of stairs as opposed to if you went up a ladder. Why do we use a set of stairs then? The whole reason is because you get to use less force, okay? If you take 500 times the cosine of 60, you get a lot less force. So you might go a longer distance, but if you get to use less force, do you care how much distance you go? No. So that's the whole point of a stairwell, is you get to use less force to do the same amount of work, even though you go a much longer distance. So when I wheel my son Adam up in his wheelchair to a ramp, what I pray for is a very long ramp, because as distance goes up, what happens to your force? It goes down, but you do the same amount of work. Okay, okay, the next thing I want to talk about is that power is the rate at which work is done. And so therefore the formula is going to be, if it has rate in it, rate is the same thing as time. So we're going to take power equals work divided by time. So we're going to do this little problem here. Let's say that Kaylee ran those stairs in 10 seconds. How much power was exerted by her? So if you notice here, what we're going to do is we're going to plug in the amount of work that Kaylee did to go up the stairs. Well, that's from the last problem. So if you notice, it's 1,500 joules. We're going to plug that in for the work. How many seconds did it take her? 10. So you put in 1,500 joules divided by 10 seconds, and you get an answer of 150. Now, what is the unit for power? Now, I said, what is the unit for power? It's a statement, guys. What is the unit for power? What is the unit for power? Of course. All right, so this is the Work Power Lab, and what we're going to do today in lab is just get this data, and then the rest is going to be due for homework. So the first thing you're going to have to figure out is the distance of the whole stairwell. How do you plan on doing that?
By measuring.
So good job, Lindsay. What we're going to do is we're going to record the height of one step in meters, and then you got to multiply how many steps there are. So the first thing you're going to do when you get out there with your group is have one person measure the height of a step. Okay, and so let's just say that when you get out there, it measures, I'm just going to make this up here, 0.17 meters, or if it's 17 centimeters, that'd be 0.17 meters, right? Okay, you got to measure it because every stairwell out there is different. So don't write down what I have up here. And let's just say you record the number of steps and you get 45. That's what's also weird about this building. There's different numbers of steps in every stairwell. Okay. Well, the next thing you have to do is calculate the vertical height. How are you going to do that again, Lindsay? You're going to take what?
The height of the stair.
Height of the step and multiply it by the number of steps. So that's how you get there. Now, it also tells you to record the diagonal length. Well, I just want to let you know that 3 steps diagonally equals 1 meter, roughly. That's pretty daggone close to it. Okay? Now it says record the angle. The angle that the stairwell is 60 degrees. So when you do that FD cosine of theta, remember this is the formula you're going to use for work, that theta is going to be 60 degrees there. Now, the next thing you have to do is put in your weight in pounds and then convert it to newtons. I am going to do this for me. So on a really, really bad day, after Thanksgiving, let's just say I weigh 220 pounds. Okay? If I want to convert my weight to kilograms and then the newtons, I'm going to tell you that there are 2.2 pounds in 1 kilogram. So you had to go back to that first week of school when we did these conversions. To get the pounds to cancel out, where do you put them? On the bottom, and there's 2.2 pounds. Then I'll put the 1 next to the kilogram, and that gives me 100 kilograms. But how do you get your weight if you're trying to find, if you know your mass? Weight equals mass times what?
Gravity.
Gravity. So I'm going to take that 100 kilograms, multiply it by 9.8 meters per second squared, and so on a really bad day after Thanksgiving, I weigh 980 newtons. And you guys got to do the same thing for your weight. But every partner out there has, every group will have a light partner, and every group will have a heavy partner. So let's just say your light partner weighed 100 pounds, and your heavy partner weighed 200 pounds. So that would be something for those people needing the data to get. Now, one more boo-boo I made. Let's look down here at the bottom of my little brackets down here. You see where it says time of the light partner, and then down here it says time of the light partner again? Scratch out that second one and make it heavy. So the second person should be the heavy partner on both of those. Okay? So you've got the time of the light person running and walking, and the time of the heavy person walking and running. And for those people that are not here, we're just going to say that you're going to do the walk in 13, the walk is going to be in 26 seconds, and the run is going to be in 13 seconds. So for all those people that took that long Thanksgiving vacation, there's your data right there. Have it done the day you get back. No excuses. Thank you and have a great day. Love you.